So we're going to start by graphing easy equations and make it more complicated, more complex, to feel more comfortable about different types of equations. The very first equation that I'm going to work with is a constant equation. So constant function, which defined as y equals to a constant like c. This is the general definition of a constant function. When you have a function like this, no matter what your x value is, your y value is always fixed. So no matter what x is, your y is fixed. It's always equal to a constant. It's not changing at all. What do I mean by that? Let us take a look at an example. Example says, well, graph y equals to 2. Okay, y is 2. What's the meaning of that? It means that no matter what my x is 1, y is 2. X is 2, y is 2. X is 3, y is 2. For any different value of x, my y is fixed. So take random x values, like 0. If my x is 0, my y is 2. Okay. What if I randomly select x to be -2? If my x is -2, it says, hey, your y value is fixed. It is equal to 2. So you're going to just copy down 2 for your y. You have 2 points. 2 points are enough. So let us graph this. Here I have my x-axis, and here I have my y-axis. My y is always 2. So 2, 1, 2. The graph is going to be y equals to 2. We have a line which is flat. The slope of this line is 0. So this is a flat line. Slope is 0. So we learned that if y is equal to 2, if y is equal to 3, if y is equal to a constant number, we have a flat line or we have a horizontal line. So in special case, when y is equal to a constant, we expect to see a flat graph. What if we have a special case x equals to a constant? So take a look at this scenario. Take a look at this case. If you have x equals to c, no matter what your y is, it doesn't matter at all. So no matter what y is, your x is always fixed. For example, if I ask you to graph, for example, x equals to 2, it means that I can select any y value that I want, but my x is always fixed. My x is always 2. Okay, for any different value of y. X is fixed. X is 2. Select any point with different y values. So the first point, suppose my y value is equal to 1. What is x? The question says x is 2. You cannot change x. X must stay as 2. Select any other y value that you want. Negative 10, negative 10. If my y is negative 10, my x is 2. That's the definition of this line. So I'm going to just copy down 2 here. So how do I graph this? It says no matter what your y is, your x is always 2. So it's going to be the graph of this line. My x is 2. And you get a vertical line. X equals to 2, vertical line. So this is a constant function, but this is just a line. Make sure you know the difference between them. After working with a constant function, the next function that we are interested in is linear function. A linear function is defined as follows. So our next function is a linear function. A linear function is defined as y equals to mx plus b. Well, m is called the slope of the line, rate of change, and b is called the y-intercept. When you're dealing with different functions, especially linear function and later on a quadratic function and more, you're interested in finding the x-intercept and y-intercept of the function. We can find the x-intercept of any function. So what is x-intercept? X-intercept or x-intercepts are the point of intersecting of the graph with the x-axis. X-intercept is the point of intersection between the function and x-axis. To find x-intercept, you set y equal to 0 and solve for x. To find x-intercept, we set y equal to 0 and solve 4x. Okay, let's take a look at one example. We have a linear function, all right? You're interested in finding x-intercept for the linear function. Let us go over a couple of examples. Suppose y is given as 2x plus 4. My goal is to find the x-intercept of this function. So to find the x-intercept of this function, what I'm going to do, I'm going to set y equal to 0 and solve for x. Let's see. Y is 0, and on the right-hand side, I have 2x plus 4. To solve for x, it means that I have to isolate my x. Isolate x. How do I isolate my x here? So step by step. First, get rid of the constant. Bring the constant to the other side. Subtract 4 from both sides. Okay, I'm subtracting 4 from both sides. What's left? I have minus 4 equals to 2x, but 4 minus 4 is just 0. So I have 2x, 2 times x equals to -4. To isolate my x, I have to get rid of this coefficient by dividing both sides by 2. Now divide by 2. To isolate x, divide by 2. So let me divide by 2. On the right, divide by 2. On the left, divide by 2. Well, this is obvious. 2 and 2, they get canceled out. So x is equal to 4 divided by 2 is 2. It has a negative sign, -2. So the x-intercept of this line is x equals to -2. Is the x-intercept. It means that at x equals to -2, graph crosses x-axis. At x equals to -2, graph crosses x-axis. So at x equals to -2, the graph crosses x-axis. Other than finding the x-intercept, we can find the y-intercept as well. To find the y-intercept, now we set x equal to 0. So we can also find the y-intercept by setting x equal to 0 and solve for y, or isolate y. Very good. So we are working with this function, linear function. I already found the x-intercept. Well, I'm going to find the y-intercept as well. Since y is equal to 2x plus 4, I simply need to set x equal to 0. So when x is 0, I have y equals to 2 times 0 plus 4, but 2 times 0 is just 0. So my y becomes 4. So my y-intercept is 4. This is my y-intercept. So what's the use of these two, x-intercept and y-intercept? They help us to graph the line without using any help. So take a look at this. I have my x-axis and I have my y-axis. It says at -2, the graph hits x-axis. So let me find -2, -1, -2. Okay, -2 is just right here. And it says my y is 4 and it is my y-intercept. So 1, 2, 3, and 4. This is 4. So now if you connect these 2 points, then you're going to have a line which is increasing. I have an increasing line. This is the graph of this linear function. Two x plus so now you have the following. 2y is equal to x plus 2. So 2y is x plus 2. First, let us find the x-intercept. To find the x-intercept, you need to set y equal to 0. So y is equal to 0. It means that 2 times 0 is equal to x plus 2. On the left-hand side, 2 times 0 is just 0. 0 is x plus 2. We need to isolate x on one side, but you have plus 2 attached to x. What are we going to do? We're going to get rid of 2 by subtracting 2 from both sides. Subtract 2. If I subtract 2 from both sides, I'm left with x equals to -2. So x equals to -2 is my x-intercept. It's the x-intercept. But if I want to find y-intercept, to find y-intercept, I have to set x equal to 0. So let's copy down the equation. 2y is x plus 2. So now set your x equal to 0. Let me use a different color. My x is 0, all right? So I have 2y equals to 2. Now to get rid of 2, 2 is multiplied by y. The opposite operation is division. Divide by 2. Divide by 2. If I divide by 2, what do I get? I get 2 and 2 cancel out. I left with y on the left-hand side. 2 divided by 2 is 1. So y equals to 1 is y-intercept. So we talked about a linear function. We went over some examples. Now we're going to talk about quadratic functions and how to find the intercept. The process, the steps for definition of X-intercept and Y-intercept, both of them are the same, no matter which type of function you're dealing with. Now we are having a quadratic function. When you have a quadratic function, you have a function of the following form. Y is equal to ax squared plus bx plus c. It happens that a, b, and c are numbers, and the leading coefficient, a, is never 0. Otherwise, we get a linear function which is not the one that we are looking for. So a, b, and c are numbers, and a as the leading coefficient is never 0. You can find X-intercept and Y-intercept of any function, especially a quadratic function. Let us take a look at the following example. In this example, we have y equals to x to the second power. Note that a, the leading coefficient, is 1, b and c are 0. A is 1, b is equal to c. They are both 0. Let us find the x-intercept of this function. To find x-intercept, set y equal to 0. So set y equal to 0. What's the meaning of that? It means that on the left-hand side, my y becomes 0. On the right-hand side, you have x to the second power equal to 0. X to the second power is 0 if and only if x is 0. X squared is 0 if and only if x is 0. So we found our x-intercept. X-intercept, or the point of intersection between the graph and the horizontal line, is 0. So x equal to 0 is our x-intercept. What if I ask you to find y-intercept? To find y-intercept, you're going to set x equal to 0. Let us copy down the quadratic function here. Y is equal to x squared, and we set x equal to 0. So my y becomes 0 to the second. 0 to the second. What's the meaning of 0 to the second? It means that you are multiplying 0 by itself 2 times. 0 to the second is 0 times 0, which is 0. So what happened? You got y equal to 0. So my y-intercept is also 0. So what's the graph like? If I want to graph this function, I'm going to discuss parabolas, which are the graphs of quadratic functions in a whole different chapter. But for basic quadratic functions, the graph is called a parabola, and this graph behaves like this. This is the graph of y equals to x squared, and we call it a parabola. As you can see, the point of intersection with x-axis, with y-axis, both of them are at the origin, x equal to 0, and also y equal to 0. Very well. So now I'm changing my function into x squared plus 1. X squared plus 1. As you can see, your a, or the leading coefficient, is 1. Your b is equal to 0, but c is equal to 1. So I want to find my x-intercept. To find x-intercept, I'm going to follow the definition. Set y equal to 0. So y is equal to 0. What's left? On the right-hand side, I have x squared plus 1. Am I right? Okay, it says x squared plus 1 is equal to 0. X squared is always positive. Plus 1 is also positive. The addition of two positive numbers cannot be 0. Okay. Or you might be interested in isolating your x. Subtract 1 from both sides. If you subtract 1 from both sides, what do you get? You get x squared equals to negative 1. X squared equals to negative 1. What's the meaning of that? It means that if I want to isolate my x, I have to take square root of both sides. Now take square root of both sides, all right? So if I take square root of both sides, what happens? It happens that x is equal to plus minus square root of negative 1, which is a complex number. Guys, we're going to talk about complex numbers in the chapter related to quadratic functions. So, complex solutions. What's the meaning of that? It means that the graph doesn't touch x-axis. So the conclusion is the graph has no intersection with x-axis. What about my y-intercept? To find y-intercept, I simply set x equal to 0. So set x equal to 0, but let's write down the quadratic function here. Y is equal to x squared plus 1 and set x equal to 0. So when x is equal to 0, your y is 0 squared plus 1. But we know that 0 squared is just 0. So y becomes 1. So y equals to 1 is the y-intercept. Is the y-intercept. So what is our observation here? If we use Desmos, graph the function is going to be like this. The function, the parabola, is going to be 1 unit upward. 1 unit moved up and it opens upward. So this is your parabola, and as you can see, there is no intersection between the graph and x-axis. No intersection. That's why we got these complex number. No intersection. This is y equals to x squared plus 1. And as you can see, there is no intersection between the graph and x-axis. That's why we got the complex solution. Very